Hey, I'm Anfa. I want to show you some progress with Liblast. So, what I'm doing right now is working on networking. I'm going to start this over. So, maybe I'm going to even enable more instances. And I'm going to start this again. So, they all spawn on the other screen in a nice little array because I've configured that. I'm going to show you how that works in a moment. And here we have a server is hosting the game and 3 clients joined the game. What you can see is that every instance is has its own ID, a 3-letter identifier in the logs. So in this, mixed digest logs that you get in Godot, you can tell which log line comes from which instance of the game because they are all marked here. All right, the problem here now is that only the server can really have authority on these players. So only using the server I can look around with every single one. And well, there's other things that come into this. So I'm at this point where, okay, the game spawns, the peers join, the like connection client server works. I have synchronized time between all the clients and the server, so they all know the same time, they have the same time reference. So now I'm coming up with structures to manage the networked state, and I want to do that for I want to do that to factor in client-side prediction and server reconciliation and lag compensation, which are all difficult things to do. And so I started sketching a little bit. Some time ago, I sketched this thing called entity. And the idea was that entity has a state and it holds a state definition, which basically maps, like short names to properties of a node. And we would probably have it like, it will either be a base node, which is like the entity is our head, and then let's say we have a character. So like we put a character underneath. So this, our base node, yeah, this doesn't want to, well, this was previously called parent because, yeah, you see now this compiles because the idea was that the entity was underneath the character. So it was like mixing root. Okay, can't do that. But the idea was that you would put the entity underneath the character. So the entity was kind of like an entity module. So the entity, we think as, we think of the character as being the entity, but because Godot doesn't have multiple inheritance, well, I want to have the character extend character body 3D, which maybe that's a stupid idea. Maybe the entity should exist. Maybe it should even be like an ethereal thing, like not a node 3D, just a node. But then again, it's well, a common spatial reference becomes a problem. Yeah, so the idea was that maybe the entity is going to be like a child of the character. And then, so yeah, instead of doing this, we do the opposite, which is have an entity here and Yeah, let's even make this a node, so not node 3D. Because, yeah, and now this is like, this would be, yeah, parent, well, basically that. And now that would be, here we would define like this, the state definition. So you would say, okay, I want the state of this entity character to be comprised of position, rotation. And so basically it's taking properties of the parent. So the character is like responsible for all that. So this would mean that, for example, the character has various components. So nodes underneath, which is like head, camera, a bunch of other things. The idea would be that the character would itself expose all of these things. So basically the character here would have to have like head rotation, for example. So we can do like export var. Actually, no, we don't have to export it. Var head rotation, and that's going to be a vector 2 because the head rotation is just, you know, left, right. Well, actually, let's go vector 3 because who knows? Maybe we want to, you know, do this like raw. I don't know. No idea. But let's do that. Head rotation, and now, well, I would have to do like a set get. Set. Yeah, I could do this in line. So set value, and it would be first thing is head rotation equals value, and then head dot rotation equals head underscore rotation, right? Similarly, the getter would be get, and it would be return head, or we could do something else. Head rotation equals head dot rotation, and then we return head rotation. So and every time you try to read this variable, it actually goes to the sub component to the head node and picks the rotation of that. Which, yeah, and then, you know, I don't know, maybe let's try it. I don't know. It's let's do it. New value key. I'm gonna call this what? Aim. And this is gonna be for the vector 3. Oh shoot, no. Sorry. I need to string name. And this would be head rotation. Right, and I add this. So now aim is head rotation. No, that's actually wrong. This should be just head rotation. Or we should compose an actual variable called aim, and then it would be composed of heads, you know, like tilt or pitch. I don't know which one is it. And then, or maybe this is yaw, and yeah, I think I should do this. Yeah, that would be a better way to do it. So this would be an aim, a vector for 2. Right, so then we would have rotation. Yeah, instead of rotation and aim, yeah, we would get rid of rotation. We would have aim, and it would be aim, and that would actually be this thing. All right, and set, and that would be like head dot rotation dot x equals aim dot y. x is achieved by our character doing left and right. No. And y, rotation, yeah, aiming in the vertical is actually our head moving up and down. So head rotation y, and then, yeah, that's the first thing, yes. Oh crap, what will happen when someone goes like aim.x equals something? Does it like, is it gonna like trigger the setter and actually have this code run or not? We'll see. So head rotation dot y, okay. And now it's gonna be rotation dot y equals aim dot y. No, aim dot x. Rotation dot x equals aim dot y. Rotation dot y, it was aim dot. Yeah. Oh, now it's called aim, not this. All right, and get. Vector2. Let's use the benefit of two lines. And the first thing is going to be rotation.y. Second is going to be head.rotation.x. And this is going to be right. So this is aim. Okay, so now the idea is that entity holds our state definition, which is position and aim. It's kind of like a multiplayer synchronizer. So we could maybe first try and do this with a multiplayer synchronizer, and then try and do this with an entity thing. Because the problem with multiplayer synchronizer is it's gonna be great, but there's no way I can like implement any kind of state prediction or like client-side prediction or server reconciliation. So I need to kind of be aware of different states, and yeah, so maybe I'm gonna just, I don't know. I'm gonna do never. Yeah, so I'm gonna try to rely on, yeah, this is head rotation, character rotation y, and head rotation x. That should be the only needed one for, in reality, head rotation y, x. Yeah, but now really it's gonna be, okay, I'm just gonna delete everything. I'm gonna delete this entirely. Okay, let's have an entity doing that for us. Okay, so character. First, let's try and restart, and we're gonna have a bunch of errors probably, and just we'll see what happens. Oh, actually, not no errors yet. Maybe there's something, but so far it looks exactly the same, and in the exactly same manner, we can only control characters from the server. We control all of them, and this time nothing syncs. Okay, so this seems like the perfect time to get our entity. So get state, return state, set state, get state packed, set state packed, process tick, right. Yeah. Yeah, I'm not sure if, I don't know how to approach this. I've been reading a lot about networking and, different kinds of doing this. There is a project called NetFox, which I was thinking about maybe using, but oh, well, too bad. We can't reach the asset library. But the problem with NetFox is that it's very, very complicated, and it also is quite opinionated and does things a certain way, which isn't really compatible with the whole idea I have behind the Liblast framework. So kind of like going with NetFox would be a little bit like having to really like think a lot of things to build it around NetFox and like adjust to do NetFox, to do everything that NetFox way, which I'm not really a fan of. So I think I'd rather reference NetFox and see how they're doing things, learn from their way of implementing things, and try and do this a bit more simply and a bit less complicated way, but still, yeah, maybe I can actually go back to this because our entity is not going to do much of anything, really. Yeah, that's the thing with, the entity is maybe it could coexist with the multiplayer synchronizer if the multiplayer synchronizer could also sync like a tick, which would be, I mean, it could be that it just fetches I've implemented this shared time, so it could like fetch a shared time and like synchronize this as part of the packet. So then every update it would do, it should contain a timestamp. So then I would pass it to the entity and like put it into a history and figure out where it happens. Like how much do we need to predict from there? Or like, do we need to reconcile or whatever? Yeah, I'm not sure. It feels like it's going to be more complicated. Well, probably the first thing I'm going to probably do is do the simplest possible thing, which is like, first don't do authoritative server, just do authoritative clients. Just the first thing to be able to have a couple people running around and, and once that's working, I can start going deeper into that. And I'm probably going to have to rewrite the control thing here because this was taken from an idea from one of the Godot team members who is like writing the networking, but I'm not sure this is a good idea, honestly, to do it. Yeah, it feels kind of messy to me, and like I feel like I've had a better idea how to do this in a previous iteration of Liblast, so I think I'm going to go back to that, only just simplify it a bit to maybe not go as deep into abstraction as I had before. Yeah, there's a lot. There's a lot happening now, and this is a very difficult time. Yeah, it's kind of this is kind of stuff which I wish I could, just take a month off work and focus entirely on that just to write this. And then I guess I could do a good job. Having just a couple hours here and there, it's difficult because there's so much you need to like load up into your head to be able to really like reason about these things. But well, we'll see. So yeah. So far, I have just, unsynchronized peers, which are kind of, everything is on the server. Yeah, now it's syncing the state, but, not the key inputs. And now the problem is that happens because they need to be all the characters, the multiplayer synchronizer, sorry, the the multiplayer spawner, which is here, it's not going to spawn anything unless the authority of it is set to 1, which is server. If I do this, they're probably not going to save. Like, okay, yeah, oh, that's a bit different. Okay, by the way, I'm going to show you how do you set up your windows for like automatic tiling. Maybe it's not automatic, but you can see this is how I do tiling of the individual instances of the game. So what I have is in Liblast, I'm gonna first just run one instance. I'm gonna remove that. I'm gonna just run one instance with nothing. Yep. So now what you can do is you can position this anywhere on your screen. Then open the console with tilde and then you can type get window, hit tab, right arrow, enter, and you have this. You can copy that, paste this here into the command line, and now that's gonna give you exactly the position you had before. So now if I run the multiple instances, I just use the first line, I'm gonna hit F5, the window is gonna appear exactly where I set it before. And I just repeat this 4 times to, divide my screen into four places for these things. I could maybe arrange it so I can still, see the editor and stuff. It's probably possible. I could spend a lot of time implementing something even more fancy to do this, but I don't think it's a time well spent. Yeah, so I could tile like the game instances like this. Maybe go like 1, 2, 3. And that's a bit large. I could maybe do this and then divide by 2, do a little math to arrive at something that is a bit more even. Now, we can try and do this. So get window rect, and it gives you a command, like a command line attribute that you can use right away. So we're going to do some math on that. So I'm going to paste this here. And now we'll see. So rect, the first 2 is position left, X and Y, so we don't touch this. Now there's the width and height of the window, so we need to divide these 2 by 2. 1951 by 2 is going to be what? 980, 925, 925, let's try that. And this, that's going to be 442. No, 432. Let's try that. Okay, and next, let's do this, but oh, now we should multiply it. No, wrong. Add the 925 to this. So that's going to be 11 2. It's going to be 7 and 5. That's going to be 7 2. Okay, so that's X. Let's see how that works. Is our math roughly correct? We should have two windows that spawned. Okay, why does the second window spawn on the second screen? That's weird. And it's a wrong size. It should be like that. Our height division also didn't work out quite as expected. Yeah, it can also be easier to do just, you know, like manually position all the windows, like spawn 4 of them. Oh yeah, I guess I just didn't save. Spawn all of them here. Manually, like put them into place. And I'm just gonna, you know, copy and paste the coordinates that they give me, which is another way to do this. Yeah, I guess we can go like this. Doop. Okay, so now get window rect. Get window rect. Get window rect. And get window rect. Okay. Interestingly, in some of them, this was printed again. There was like feedback from the native log, and some of them there wasn't. Okay, debug, customize, run instances. Can I? Okay, that's going to be a little bit difficult. Maybe it's going to be able. It's going to be possible. Okay, so we can. If I can, maybe. Okay. So that's the first one. Let's copy and paste the rectangle. I'm going to show you what I'm doing. Now, put this under another one, copy. So this is, oh, CL2. Okay, that's, okay, so that's the wrong, this is going to be CL2, right? Yeah. CR stands for client, of course. This is CL1. Oh, these are swapped. Oops. Never mind. And the last one is here. Does Control-C work? Can I copy? I guess it does. No, it doesn't. That doesn't seem right. I think I need to. Yeah, no, you need to manually do copy. Okay. Right. Fine. Let's try again and see if this just, you know, arranges as it should. Everything outside of one instance. Where's that last one? Where's the last instance? Did it crash? Unspotter node session free. Where is it? Client 3, yeah. Client 2, 1. Okay, I guess we copied something wrong. This shouldn't be here. It should be a bit. Oh, dude. Okay. Get window rect. We need to correct that. And this is for client 2, CL2. Debug, customize run instance is CL2. Of course, yeah, it has the same line as, I think I should have, I probably made a mistake somewhere with copying and pasting. Okay, let's hit F5 again. Right, now we get everything here. That's great. So yeah, this is how you can set up your working environment to, you know, have Liblast spawn multiple instances wherever you want. We could also make these, stay on top. And I would probably do this by Godot's parameters, like T, always on top, because there is parameters like that. So I don't have to implement that. So I could just go T. Dash T. Dash T. Dash T. Okay, and that should make these windows stay on top. So that so now, the Godot editor cannot, does not, doesn't get on top of it. So now this can be very, very cool because you can still do some nice debugging. Say you want to, for example, you can switch the sessions, go to remote state, and you can, for example, go game peer, game characters, and you can check and select. Right, so we are on the server, and we can select each individual character. We can switch to a different. This is going to be a client game characters 0. Interesting. I can see any highlighting. Oh. Oh, now I can. Okay, that's so weird. Okay, so I can mouse look. It's not synced though. And walking moves everyone else but you. Oh, on the server it does. Yeah, so the syncing is pretty funky. Yeah, so that's what I'm working on. If you wanna hang out, talk, to help with this, or have any ideas, you can go to liblast.st and click on chat. I'm gonna show you. You can go. Can I do this? I can. Yeah, so you can go to liblast.st, and this is the website of the project. These are all the versions. You can go to chat, and you'll get to Zulip chat, which is the place where where the development of this thing happens. You can also get our code, which is on Codeberg. And I'm doing work right now in the Liblast Framework. This is the repository I'm working on, and right now I'm in a branch called the Devil Alpha. So this is not on main because I'm doing things that are breaking stuff. So I'm gonna merge this to main with a pull request once it does. Yeah, but this is exactly what I'm doing here. Yeah, so that's that. Oh, I've been in the way this whole time. Yeah, so the code is here. The chat is here. Chat. Code. Social, we are on Mastodon. We are on YouTube. PeerTube. There's a thread on... Oh, where is that? I forget. On Godot forums. Does it even work still? Because I think the forums was taken down and brought back to life. Maybe, yeah, the website might be a little tiny bit out of date sometimes. Yeah, the screens are very old, honestly. That's from previous iterations of the game, really. Yep, this is the so-called rewrite, and yeah, this is the Liblast Framework, so this is what I'm doing now, and this is from Legacy. Okay, that's all. Thanks for watching. See you.